Okay, well, so those video presentations were tremendous. Thank you all. I would like now to give a summary presentation on cross-cutting themes that have occurred across the whole workshop, and then we'll go into the discussion. So the workshop began on May 4 with an introduction to Argo and biogeochemical Argo. And one of the things that was clear, I believe, from those presentations is that biogeochemical Argo is being tremendously successful scientifically. I have just clipped a few shots of articles that have been published in the highest profile journals, highlighting some of the really transformational scientific discoveries that have come from biogeochemical Argo. And the number of scientific publications is rising exponentially. We know how to do science with the biogeochemical Argo array. The purpose of this workshop really has now been to extend that knowledge that we're learning, the transformational understanding of ocean processes, and extend that really to actions that increase the societal relevance of the system. And so we had 3 separate panel discussions. May 11, fisheries and fisheries management. May 18, carbon budget verification and validation. May 25th, biogeochemical modeling, data assimilation, and forecasting. Today focuses to bring you the summary perspectives and panel discussion. But from those 3 topical discussions, I think it's very clear the applications in fisheries management, carbon budget validation, environmental forecasting, there is a direct and valuable role for biogeochemical Argo in fisheries in providing oxygen fields of primary production in the ocean, nitrate, nutrient supply in the ocean, chlorophyll abundance, effects of pH, acidification in the ocean. Carbon budget validation, the fields of pH allow us to estimate PCO2, the CO2 partial pressure in the ocean, air-sea carbon dioxide flux, primary production, and the carbon export from the surface ocean, the carbon pumps that drive much of the CO2 flux, chlorophyll fields that drive those pumps in many ways. Environmental forecasting, it's clear that having fields of oxygen, nitrate, pH can improve our understanding of ocean physics and engender predictions of future trajectories of productivity and chlorophyll stocks in the ocean. There are clearly applications for BGC Argo in all of these areas. And what we'd really like to look at here are some of the cross-cutting issues that arise from these. And thanks to the very careful notes from our note takers, I will just work through a few of these cross-cutting issues. And in the discussion with the audience, we'd like to focus more on other opportunities. So this is the focus today. And I think one of the clear issues that came out in all of the discussions is multi-platform synergy. So this is a BGC Argo workshop, but it's clear that the interaction between Argo, satellite observing systems, ship-based observations produces a system that has much more synergy than just any one of these systems alone. In many cases, BGC Argo is strongly dependent. And so this is encapsulated by this diagram showing the ship collecting data, deploying floats that extend the ship's observations in time, the floats connecting to satellites to transmit data, but also this Earth observing satellites providing much higher resolution fields than we can achieve with Argo alone, the floats extending those observations into depth. We are really talking about a synergistic multi-platform system that will be greater than any one of the individual components. But to make that work, it's really going to be necessary to have an interoperable data system. all of these platforms, multiple platforms, will require transparent data systems that provide quality controlled data in real time that is unbiased across the various platforms. This is a figure from Fei Chai's talk in session 4. BGC Argo must work in synergy with the other components of the global observing system. A chlorophyll observed by the floats needs to be compatible with chlorophyll observed by a satellite or observed in ships. And we need a data system that allows us to merge all of those products. It is clear each of these systems has its own great individual data system, but we do not have a fully interoperable system yet. Also clear in all of the talks that we've had that there is a strong connection to the coastal system. BGC Argo, primarily an open ocean observing system, but it will provide essential benefits to our understanding of coastal processes. But fully realizing the benefits of BGC Argo also will require extending open ocean observations into coastal systems with other autonomous platforms, gliders, autonomous surface vessels, wave gliders, or sail drones, coastal profiling floats. So a figure from Charlie Stock's talk in session 2, most of the world's fisheries are in the ocean's margins, and clearly the open ocean data is essential to understanding margin processes, but we would like to fully realize the benefits, extend the observations into the coastal zone. Data assimilation. So it is clear, I think, in the talks that the value of these autonomous real-time observing systems is to provide continuous, robust data streams for model efforts that will both predict future trajectories, but also be used to understand change in the current ocean at higher resolution than floats or ships or satellites can provide in the vertical. So data assimilation is an area where there needs to be continual work. We're in the early days of biogeochemical data assimilation, and we need to continue to focus on that. Multiscale models. So BGC Argo will be instrumental to derive global and regional four-dimensional fields. The global fields will then be invaluable to constrain the boundary conditions in coastal models and ultimately to be extended in high resolution into coastal zones. There are a variety of processes in the coastal zone that are not well understood. A figure from Sarah Mikaloff-Fletcher's talk in session 3, unexpected carbon sinks in the coastal zone, more CO2 uptake than expected. We need to be able to predict and observe this in ways that, again, will require BGC Argo observations, biogeochemical observations to be extended into coastal areas. Observing higher trophic levels. It was clear in talks in fisheries and the carbon budgets and many areas of forecasting that extending observations to higher trophic levels is essential. In fisheries, a figure from Patrick Lahode's talk in session 2, the behavior of large oceanic species is linked to the distribution of their prey, micronecton. Bob Bruin's talk on the biological carbon pump, the various carbon pumps in session 3, heavily linked to topics like zooplankton migration or gravitational sinking of fecal material produced by zooplankton in the upper ocean. To really understand this, the system will be much stronger in the future if we can extend it to higher trophic levels. In terms of challenges, there still remain a variety of them. Completing the biogeochemical array, the science and implementation plan calls for a 1,000 float array, an internationally sustained array. There are now 15 nations with biogeochemical floats in the water. Other nations have participated in the past. It is an international system, but it is also incomplete, and there is uneven coverage in various regions of the ocean. We need to work to and train additional nations and train coverage in all regions of the global ocean. And completing the array also requires profiling floats to carry a greater suite of sensors. This figure, by the way, these are from the oceanops.org website, produced monthly, shows the number of biogeochemical sensors carried by each of these floats. This flower diagram, if it has 6 bars on it, that's a fully complete float that carries oxygen, nitrate, pH, chlorophyll fluorescence, particle backscatter, and irradiance. Many of the floats carry only one of the particular biogeochemical sensors, very often oxygen. So we see the North Atlantic, most of the floats have only one or a few of the sensors. The Nordic seas begin to be well covered though. We need to extend the operation to ensure that the full regional coverage also is full multi-sensor coverage in the system. Challenges training users. There is a significant need to train users of the data. It's a new way of thinking about the ocean. The data sets are larger, they are more complete, and yet you also realize that that very often they have limitations in terms of the number of variables, in terms of not having the higher trophic levels, as an example. So efforts are underway to increase the number of scientific users. There's a workshop coming June 28 to 30, sponsored by the U.S. Ocean Carbon and Biogeochemistry Program to train science users in the data. But there is not yet a comparable effort to train end users at the various management levels where we would be incorporating this data into ocean action and fisheries management, so on. That is a clear missing element. We need to train users at all levels. And ensuring global access and benefits to the system, we have to proactively enable less wealthy nations to utilize the systems, realize its benefits. I was particularly struck by the talk by Srinivasa Kumar in session 2 on the work that India is doing in this area. INCOIS, the Indian Center for Ocean Information Systems, has been extremely proactive. As you see, capacity development in Malaysia, the Maldives, Mauritius, the Sultanate of Oman. As a global system, we need to support this kind of work. The global system has to benefit all nations, not just the more active participants. And so this, I think, in the Indian model is a great example of how we can move forward in this. Challenges long-term operation. So we have heard a lot about the core Argo program and the tremendous knowledge. Jane Lubchenco, described its transformational benefits, and it is clear that it has been transformational. Much of that stems from its long-term operation, as shown in this figure of the ocean temperature anomaly from Toshio Suga's talk in session 1. In any one year, we don't see the anomaly of temperature. We need to operate systems for sustained periods of time to see the evolution of processes in the ocean. And so long-term, there's much we can do with data from biogeochemistry from any one year, from any one season, understanding seasonal cycles, but many of the benefits will depend on long-term operation of the system, which right now is primarily funded through research grants. So opportunity. The funding by the U.S. National Science Foundation of the Global Ocean Biogeochemistry Array really has laid the groundwork. Well, the groundwork's been laid by a variety of science programs internationally. Smaller scale has grown to the SOCOM program in the Southern Ocean, but now we have a program that extends the array globally, forms a strong basis for operation of the planned 1,000 float global array. Huge opportunity. Second opportunity mentioned by Jane Lubchenco, Gideon Henderson, and others is the UN Decade of Ocean Science for Sustainable Development. And today is the day of the major announcement of the UN Decade. It's a huge opportunity for us. We need to engage closely with the UN and their international efforts to build the global system that we envision, to be able to transform the ocean science knowledge that the system generates into actions to sustain ocean systems.